Hi everybody, and welcome to this very quick review of one variable statistics. So we're going to talk about these things, and we're going to find them using this data set. So let's just jump into this example. If I want to find the mean of all of these values, I know that I need to take the average by finding the sum of all of these values, let's call those x values, and dividing by the total number of values. If I have a mean of a set of data, so a sample mean is denoted by the symbol x with a bar over it, which we call x bar. If I have a population mean, that's denoted by the Greek lowercase symbol mu. To find this using the calculator, I'm going to start by creating a list by going to Stat, Enter on Edit. Now if I already have some data in here and I want to clear it all out efficiently, I could just press the arrow up and press clear with my cursor on L1 to clear that data set. So now that I've got an empty list, I'm just going to enter this data in the order I see it. So I've got 80, 76, 74, 52, 90, 88, 58, 64, 72, and 82. All right, now that I've got that list created, I'm going to find a lot of these things by using the one variable statistics function on the calculator. And I can find this by clicking Stats and then going over to Calc and then clicking Enter on one variable statistics. This asks me for the list I'm using. I'm using list 1. Since this is not a frequency distribution, we can just leave that blank and then calculate. This gives us a lot of stuff. Starting off here with the sample mean. So when we're just asked to find the mean of a set of data, we are assuming for our purposes that this is the sample mean, that we want the mean of this sample. And so that's going to be 73.6. So our mean is 73.6. Now for our median, we can also find this in the one variable statistics by arrowing down a little bit, and we are given the median to be 75. If we were to find this by hand, we would just write these numbers in order and then choose the central number. And so our median is 75. And if we have an even number in this set, then the median will be the average of those central two numbers. For the mode, which is the most commonly occurring number in this list, we don't actually have this on the calculator, but we can find this easily by just sorting our given list. And so to do that, we're going to go back to Stat, and we're going to sort. We're going to press this Sort A, which means sort in ascending order, so from least to greatest. And we're going to sort list 1. And so I see this little blue list 1, which means I can press second 1. Closing those parentheses and pressing enter executes that. So this tells me that my list, if I go back into this list, should now be ordered. Great. Now I can easily find the most commonly occurring number. So I'm looking for any number that occurs more than once. And because I see that there are no numbers that occur more than once, this is a great example of something with no mode, because we can have no mode in this case. We don't have any repeating numbers. For our range is just the difference between the highest and lowest number. So I'm actually going to go back to one variable statistics. I could just use this list too. Let's go back to one variable statistics and scroll down to find the minimum and the maximum. And 90 minus 52 is 38. And so our range is 38. As for the mid-range, which is different than the range, we're just taking that same min and max, which we found to be 52 and 90, adding those two values together and then dividing by 2. So adding 52 and 90 and dividing by 2, and I know that 142 divided by 2 is 71. And so the mid-range is 71. The standard deviation is really useful. We're going to talk about it a lot more in this class. It's essentially the measure of variation in a set of numbers. You can also call it the average distance of a value from the mean. So what that means is if I have two sets, and one set describes the weights of Oreos in a pack of Oreos, I can guess that those Oreos are going to weigh roughly the same. Which means if I choose any Oreo from the pack, it's very likely that the weight of that Oreo is going to be equal to or very close to the average weight of all of those Oreos. If I have a set of the weights of various animals, from anywhere from a humpback whale to a bug, if I take any one of those animals out of that set of all animals, I am guessing that the weight of that animal is going to probably be a good bit different than the mean weight of all animals. And so to describe this idea statistically, I could say that the standard deviation of the weights of all animals is very, very high, while the standard deviation of the weights of Oreo cookies is very, very low. And so to find standard deviation for this data set, at least to find the sample standard deviation, because this is a given sample, I could say that S is equal to the square root of the sum of each given value minus x bar, that sample mean squared, divided by n minus 1. So this is our formula for standard deviation. And this is something that you would have calculated by hand in Statistics 1, but now we're just going to use the calculator for this. Going back to those one variable statistics, our sample standard deviation is given by the symbol SX. And so that's going to be 12 and usually we'll be given some sort of rule of rounding. For now, we can round to 2 decimal places to find that that's 12.47. So our sample standard deviation is 12.47, where S is the symbol for a sample standard deviation. So this is a sample, and a population standard deviation is given by the Greek letter sigma. We can see that on our calculator here. Now the variance is just the standard deviation squared, and I won't really talk about what that is because we'll get into that much more in this class, but using our one variable statistics, we're just simply going to square the standard deviation. And I'm going to use another few decimal places just so that variance is also accurate to 2 decimal places, and so I'm going to square the value 12.4651. So just by exiting out of that and squaring 12.4651, I get a variance of about 155.38. And so since our variance is just the standard deviation squared, we're talking about a sample standard deviation, I can just denote this that S squared is, we said this was 155.38. Now, because we're not specific about what this data set represents, we don't really have clear units. But the important thing to know here is that because the variance is the standard deviation squared, whatever the units of this standard deviation are whatever units all of these values are. And our variance is going to be those units squared. And that is it for a refresher on one variable statistics.